Hello, wicked good Ember. All right, we're going to talk about push patterns with Ember and Ember data today. We'll talk about what that means in a little bit. Those are my daughters. They're on the left and right. And when I'm not doing dad stuff or coding, I like to play beach volleyball. Yap and Yap Labs. Yap's a consumer mobile startup, and Yap Labs is our Ember training and consulting division. And as Brian mentioned, Ember NYC consumes a bunch of time too. If any of you who are not New Yorkers find yourself in New York, definitely check our meetup site and come join us at an event. We have a lot of fun with it. So what we're going to cover today is first what we mean by push. We're going to talk about the push transports that you can take advantage of in the browser. We're then going to talk about 4 patterns for using push with Ember, and then we'll do a quick wrap up. And as we go through that, we're going to be introduced to each section by a photo of Boston. So I like to learn a little bit about the cities that I'm traveling to. This particular photo, wow, it's hard to see, huh? Well, that's 4:45 a.m. Boston skyline. I'll put these slides up after so you can enjoy it in its full glory. So to define what we mean by push, let's talk about what we mean by pull. Pull is, in my parlance, a typical HTTP request. So you've got a browser over here to your left, server to the right. Browser makes a request, say for a JSON API endpoint, and the server responds to that request with some responsive application/JSON MIME type. With push, on the other hand, the server decides what to send and when to send it. So the browser's responsibility with push is to open up a channel of some sort, and then at that point, it's in the server's hands, gets to decide when to push what down. And it's just as appropriate. That tends to be that there's other stuff going on in the overall ecosystem of your application, maybe another user doing things, maybe external data sources updating. And to get a sense just kind of viscerally of what we mean by push, an example of it, I want to take us way back to a page of push history. This is the Church of the Covenant. It's in Back Bay, Boston. Beautiful old church. We're not going to go quite that far back, but instead we're going to go to 1997 when Wired magazine had on its cover, remember the browser war between Netscape and Microsoft? Well, forget it. The web browser itself is about to croak, and good riddance. In its place, push. And Forbes definitely agreed. It was heralded as the killer app of the late 90s. There was even speculation that it would make the web browser obsolete. And the poster child of push was Pointcast. By show of hands, who remembers Pointcast? Okay, everybody who's my age or older. So a Pointcast was an application. You downloaded it, you installed it on your Windows machine or Mac. And it was amazing because it just sat there and it updated. And you could see the news coming through. You could see stock prices. It was super hot. Microsoft agreed to bundle Pointcast with every Internet Explorer install. And I was like, wait, why would they do that? And then I remembered in 1997, Microsoft was trying to kill the browser. And so bundling something that was kind of cooler than the browser and not a browser was a good way to stick it to Netscape. It was incredibly hot at Internet World in spring of 1997 in LA. Building inspectors had to temporarily shut down the conference for fear of the crowd surrounding the Pointcast booth. So they rejected a buyout offer from News Corp in 1997 for $450 million. The next year, 98, they pulled their IPO. Climate wasn't right. In 1999, they sold the company for $7 million, and in 2000, Pointcast pushed its last bit of data. So boom and bust. That is your .com history lesson for today. And in truth, the browser has won the push war, and we're going to see in this talk about how you can do all the things that Pointcast did and way cooler stuff in the browser. And so to think about that, and before we get into the Ember patterns, we need to understand how the browser can do this. And these are push transports, and this section is brought to you by Boston's bike share program, Hubway. We're going to cover 4 things: polling, long polling, server-sent events, and WebSockets. There are others. Flash sockets, or XML socket via Flash is an example. I'm not going to get into that, although it's interesting. So polling is the absolute most basic. And in polling, you could argue that it's not really push. I would kind of agree with you. You would make an XHR request to check for updates, and then you'd wait a few seconds and make another one. And so you would kind of get updates as they become available. The problem, of course, is that if you wait 5 seconds for this and some interesting event happens in the outside world at second one, your user doesn't know about it for 4 more seconds, which is not really push. And so being armed with just this basic XHR technology in the browser for many years, people came up with the idea of long polling. And so what's long polling? You start off the same way. You make an XHR request to check for updates. If there's an update available, then the server would respond immediately. And as soon as the server responds, we reconnect. If there's not an update available, then instead of the server saying, no data, it just holds the connection open. And eventually, data becomes available, it responds, and the cycle continues. And so in this way, you can pretty much be guaranteed that you're getting relatively quick responses when new data becomes available that the server wants to push down, but you're paying quite a cost of overhead in kind of each one of these HTTP connections for no real good reason. And so with HTML5, the browser vendors and the standards bodies set out to try to address this, and they did it with 2 APIs. The first one we'll talk about is server-sent events, or from a JavaScript perspective, the event source API. And the way that this works is that it just uses HTTP. The browser makes a request for an endpoint, and the server responds with a type of text/event stream. After that initial response, it can send down response after response as long as that connection is open with a very simple text format. It's double new line separated. There's a few other nuances to it, but pretty straightforward. The cool thing about the server-sent events is that you can implement it on the server side with just HTTP. So you can write a simple PHP page that implements the server side of this if you wanted to. The next one, more flexible, more powerful, and probably more famous, I would say, is WebSockets. And WebSockets, the initial handshake is over HTTP, but then the connection is immediately upgraded to a WebSocket connection. And this connection provides bidirectional full duplex communication. And by full duplex, I mean either side can can send a message to the other side at the same time. There's no kind of waiting for one or waiting for the other. Very powerful. You need a particular WebSocket implementation on the server to do this. And so just to kind of compare the two, to think about these 2 HTML5 methods, server-sent events, unidirectional, just server pushing down to the client. WebSockets, bidirectional. I mentioned HTTP protocol versus WebSocket. The data format I talked a little bit about for SSE. It's pretty simple and text-based. For WebSockets, it's arbitrary. It's up to you, which is great in terms of flexibility, but not great in terms of kind of having standards that we can rally around quite yet. And finally, for browser support, you're good really for either of these in most modern browsers. IE doesn't support server-sent events yet at all, but you can polyfill the event source API pretty easily. And they're out there. Those libraries are out there. WebSockets ostensibly has support, but there are kind of quirks in some of the browsers to deal with. So one of the interesting things, just in thinking about the server side of this, as a quick tangent, we're going to talk mainly about the JavaScript side, but the server side, you tend to find that the server pieces of these push architectures are fairly commoditized. And by that I mean they don't really contain a lot of your proprietary business logic for the app that you're building. They're really just kind of this extension of a transport mechanism. It's how do I route this message to the right channel that's the right browser that's listening. And so I just want to point out one commercial service that I really like, Pusher.com, some similar ones, PubNub and Fanout. And the way that it works is that your server here is on your upper left. You can publish via a REST API to Pusher, and then Pusher handles communicating over WebSockets to the browsers that are connecting to it. So you don't have to worry necessarily about, well, how am I going to hold all these connections open and keep track of what user's listening on what channel and this stuff. definitely would recommend integrating something like that into your architecture. And there's plenty of open source solutions too. The link, which I'm sure you can't read at the bottom, has a great list, and I will share that on Twitter. So let's jump into how do you do this with Ember. We're going to look at 4 different patterns, kind of in varying levels of the depth. The first one is called Push Channel, and it's brought to you by the 4-Point Channel here in Boston, which I believe we're close to. Any Bostoners, is that true? We're nearby? Excellent. So again, apologize, hard to see. These are great photos, trust me. So the idea of Push Channel is, in the spirit of Ember's architecture, we're going to create a conventional approach to dealing with these push messages. And it's particularly well suited to Ember apps that aren't using any kind of data library. So if you're just using $.ajax, this is really great. It can be useful in other circumstances too. To understand the push channel approach, it's useful to understand the way that these things are, that kind of publish subscribe is typically organized, which is a great metaphor for thinking about this relationship between the clients and the servers that are pushing data down. And the basic idea is that as a client, you subscribe to one or more channels that you're interested in. That might be a channel named for your user ID or for the piece of content that you're looking at right now on the screen. And then apps publish events to those channels, and that server glue that keeps track of who's listening to what channel is responsible for routing those events to the right place. And often events have names, so these are events that are sent over the channel. Often they have names and payloads, and that's what we're going to assume for the purposes of this push channel. If you use the commercial library I mentioned, Pusher, or the SaaS product Pusher, that's exactly how they organize it, and so that's what we'll use in this example. So in the basic push channel architecture looks like this. On the top left, you've got your Ember route, and your Ember route sets a channel name on a push channel. And it doesn't necessarily directly set it. It might set, in this example, we'll see it sets the model, and the push channel can kind of derive the channel name from the model. But the key thing is the push channel ends up with the channel name, and when it gets the channel name, it subscribes using the push JavaScript client, who in turn opens the connection and subscribes in the server. When the server is ready to send data down, it kind of sends it, we go back in the other direction. The server pushes an event down for the subscribe channel. The JavaScript client routes it to the push channel that made this subscription. And what it does on this push channel is it triggers it triggers an action that matches the event name. And by action, you might think of action helper in Ember, and that's exactly the model that we're using here. And so just like actions in Ember, the way that they flow through controllers and routes, if a push channel doesn't handle the action itself, it will delegate up to the route, which is its target. So the inspiration for this, as I mentioned, is the way that actions flow. And so the Ember's kind of built-in pattern is that a route sets a model on a controller. The controller renders, or template is rendered with the controller and displayed to the user. The user interacts and triggers some action, often by clicking on a button, say, or a link. The helper then sends the action to the controller. The controller can either handle it or delegate that up to the route. And so we're trying to borrow these concepts that we've all learned about to create an easy to understand and easy to work with model for dealing with push. So how do we do that? So that's kind of the concept, but how do we do that in code? How do we make it kind of blend this seamlessly into Ember? And so what we're looking at here is the base class for a push channel. So each push channel that you want to create, you would subclass it, and this base class is what you would extend from. And you'll notice I'm using the ES6 syntax that Joe introduced us to this morning, the ES6 module syntax with export default at the top. You'll also notice down here at the bottom that this subscribe to channel method is decorated with a .on init. And for those of you who haven't come across the syntax, this basically means that this method is going to run when this object is initialized. And the subscribe to channel method is going to subscribe to the channel that's defined here. And you'll notice that there on lines 3 through 5, the channel name must be implemented by the subclass. And it's going to register a callback. And the callback is going to say, this.send. Here looks like around line 10. And this .send, you might wonder, well, I don't see send defined here. Where is this coming from? And it's coming from the fact that we've mixed in Ember.ActionHandler into this base class. And Ember.ActionHandler is a mix-in that's part of Ember Core, and it's the thing that's mixed into views, controllers, routes, anything that knows how to handle actions. So we're able to leverage and get a lot of functionality kind of for free just by leveraging what Ember has internally. So this is cool, except for this is not really quite good enough because the channel name might not be known when we first initialize this class, or it might change over time. And so we're going to enhance this just a little bit. And so we now have a subscribe to channel method and an unsubscribe from channel method. And instead of just decorating it with .on init, we're also going to decorate it with observes channel name. So anytime the channel name property has changed, this method is going to fire to subscribe to that channel. But we also want to unsubscribe to stuff we no longer care about. And so we're going to use the observes before method down here on the unsubscribe from channel method. Sorry, right down below here. And so this will observes before fires when a property is about to change. And so in a method that's triggered by observes before, when you say this.get in that property name, you're getting the value before it changes, which is super useful for something like this where I want to unsubscribe to the old channel. So hopefully we're learning some cool Ember stuff as we go. So we need to now wire up everything so that this stuff works. And the way that we're going to do that is by registering our own injections. And this is exactly the way that controllers are connected to the router behind the scenes. And we're going to do that ourselves. And so the first thing that we're going to do is we're going to create a new instance of our JavaScript client for Pusher. And so as a vendored library, we have this push client. We're going to say instantiate a new instance. And we're going to register it with the container under the key pusher main. And we're going to pass this option at the end, instantiate false. So typically when you register something with the container, you're registering a class factory. And so when something asks the container for something, it's going to call create on it. In this case, there's only one of these instances. I only ever want there to be one, and I've already got it. And so I'm just going to hand it and say, container, please don't instantiate this, just hand it out when necessary. And then we're going to say, and we would like you to inject this pusher main idea onto anything of type push channel. And so that's what this container injection thing does. You read this as saying, I would like to register an injection on anything of type push channel to set the pusher property to the pusher main instance. That's kind of how to read that injection line. And then finally, to have the relationship that we described between the push channel and the routes, we're also going to set the push channel's target to router main. This is part of how Ember Action Handler works. If it doesn't find an action on this object, it's going to look to the target and try to send it along to there. So this is how you can make, we're going to make push channel work just as natively and seamlessly as routes and controllers do in Ember. There's one more step to make this happen, which is that these push channels need to get instantiated, for one thing. If they are just classes, they're never going to do anything. And they also need to be able to have the information to set their channel name properly so that everything that we did so far, all the code was actually going to be useful. And so to do this, we're going to reopen route, reopen the Ember route class. And so what reopen means is basically gives you a chance to redefine any methods. It works essentially as a mix-in. And so at the very top, you'll see the setup method that Robert Jackson in his talk described to us as part of Ember route. And the first thing we're going to do on line 3 there is call super so that we get all the existing functionality, including setup controller. And then we're going to figure out the push channel name. We'll allow an override or default to the route name. We'll instantiate a push channel, which delegates to push channel 4. Here, his implementation is there on line 8, does a container lookup. And finally, we'll call setup push channel, equivalent to setup controller, which if we've got a push channel, it's going to set the model on it. So again, we're doing all these things that we learned about that we've learned how to work with controllers, we can apply to how to work with these push channel objects. So finally, we can use this thing. And let's say that we've got a scenario where it's some sort of blogging app and we've got a post. We're looking at the post, so we're on a post route. And there's a path where the user can publish the post, and there's something that takes a while. So we kind of send this publish request up to the server, and we want to push an event down when publishing is actually completed, so we can let the user know that it's done. And so all we're going to do is we're going to import the base class up at the top, import push channel from its module path. We're going to define channel name as a property that's based on model.id to return the channel name that is known to the server as the thing that's going to have its events pushed down. And so a nice example, usually a good way to do this is to take the ID of the object, prefix it with the type, and you've got something kind of the right specificity. So in this case, post-5, for example, if it was post5. And then all we need to do is define an actions hash, just like we would in a controller or route, with the name of the event that's getting sent down and take some actions. In this case, I'll just set a Boolean on the model, which then my UI can reflect. So this particular version that we just looked at converts pushes to actions in Ember. I've done a version as well I've implemented it with Ember.evented mixed in and converting these push events to events. Both work pretty well. It kind of depends on whether you always want to make sure that you're requiring these things and get an error if you don't, or sorry, handling these events and get an error if you don't, or whether you want them to be more optional. So that's push channel. Our next pattern I call push to data store. This is the MIT Stata building. It's a pretty wild looking building. Stata Center, I think it's called. And the idea here is we're using Ember data, and we want to leverage the fact that we've got this data store by pushing fresh data directly into it and letting all the rest of our data binding magic work. It's a very simple, but a really pragmatic and powerful approach. So let's look at how it works. This is classic Ember. You've got, with Ember data, you've got a data store. Really, it doesn't have to be Ember data. It can be kind of any data library that implements an identity map and lets you update information. So you've got models. The controller is given a reference to the model, and the template then presents that controller's data, including proxy and model data. So we've now got our server, our push client, and our store updater. Our server pushes some JSON down. We might be using server sent events, for example. The JavaScript client, in this case maybe an event source API, knows how to, has a callback, which knows how to update the data store. And at this point, once you update the data store, thanks to Ember, bam, everything updates. So pretty simple. In fact, we can look at the implementation, all fits on one slide, quite a bit different from the last one. And this one's implemented as an Ember initializer. So we say we want to just start listening as soon as our Ember app boots up. We want to, this after line helps Ember order these initializers properly. So we want to make sure that the store has been initialized first. What we do here is we're using the event source API that I mentioned. It's a very simple API. It lets you say new event source with a URL. In this case, we're going to connect to /streaming. And then later on line 8, you can say source.add event listener. There's a few different kind of events that event source emits. In this case, we're just going to use message. We create a closure to the store by looking it up from the container. And then anytime we get this message, right here on line 9, we're going to say the equivalent of store.pushPayload with edata. We're using this Ember run syntax so that we can avoid an auto run, because whenever you're dealing with kind of events that come from outside of Ember, you typically want to wrap those in a run loop. And so that's the whole thing. An interesting note here is that push payload in Ember data expects the exact same format that you're sending your API responses down in. And so what this means when you think about your server-side implementation is ideally you want to use the same JSON serialization that you're using for your API responses for doing this push data. Active model serializers for Rails makes this really easy, but definitely be wary if you've got kind of a back-end system where where it really thinks about JSON serialization as a view layer concern. That can sometimes be awkward in using it for push. Not usually something you can overcome, but something to be aware of. Finally, just kind of a note on API changes. As you may know, Ember data is pre 1.0, which means that the API might and probably will change. Yes, Igor actually tipped me off to this. So we called push payload in our example with no type, and that works for some kinds of JSON payloads where the types are top-level keys, where you can, and there's some way to glean what type of data you're pushing. But the standard Django REST format, for example, doesn't have that. It just pushes kind of name and property values. And so that can be challenging. You need to push with the payloads. And really, because of this confusion, we'll very likely see some API changes in this area to help people be less confused about this. Now, I implemented this with a client not too long ago, and it can be kind of subtle because this data just kind of comes in, and numbers might update in different parts of your UI, and maybe that's good enough. But if you want to call attention to it, I would highly recommend checking out Edward Faulkner's EmberConf talk. Edward is speaking a little bit later today on a different topic, but he's got some awesome examples of how to do bindable properties that animate. Our next section is brought to you by the oldest seats in baseball at Fenway Park. We call it Find Subscribe. And the idea here is to expand Ember Data's vocabulary to include the concept of fetching a remote resource, but also subscribing to changes on that remote resource. So here's the basic idea. In a route, instead of calling find, well, as you typically might, you would call find subscribe. The store would then call find or find query, depending on the kind of thing you're looking up, on the adapter, and then also call subscribe. And subscribe would delegate to some sort of subscribe-capable transport. This might be WebSockets, might be the event source stuff we talked about, which would then delegate to, and here's an interesting thing, some sort of subscribe-capable server, so that you can have flexibility enough to say, like, I'm interested in this particular query, and I want to know when it updates. At that point, it's in the server's hands, and the server at some point will push an updated payload back to the subscribe-capable transport, which can push it back into the store and have things work the way we expected. So an example of usage of this might be in a route. In our model hook, we call this.store.findSubscribe, looking up a post, for example. And in deactivate of that route, we would call unsubscribe, because this is consuming resources, kind of every subscription that we would create in this approach. Now, I thought originally, as I was putting this talk together, about showing how to implement this, and I looked at how we've tried to implement it, and it's pretty brutal. It's pretty complex, and mainly that's because Ember Data doesn't really have the right hooks for it today. So we've implemented it sort of by brute force, overriding lots of pieces of Ember Data. So Steph has a rosier picture of our implementation than I do, which is probably legit. He did most of the work. So the reason that I wanted to include this, though, is that it's a really nice API. The ability to say, like, hey, I'm interested in this data and I want to know when it changes in one line could be pretty powerful if we're able to figure out the right way to approach it. So our last pattern, which is brought to you by a transformed version of Cambridge, is operational transformation. The idea here is to embrace the most robust to date approach that we as a software development community, as a wider community, has come up with today for distributed editing and dealing with conflicts, offline synchronization, and that's the idea of OT, or operational transformation. And then the concept is, how can we make this Ember-y? How can we make it so that it interacts with the rest of the Ember ecosystem well? A little bit of context on OT. Research began 25 years ago, 1989. The first few years were going along pretty well until people realized that, like, oh, it just totally doesn't work. So then there was, busted in a bunch of edge cases. So then there was another kind of big push and it's become something that is pretty powerful. If you've used Google Docs and marveled at how it's able to deal with multiple users editing at once, you've experienced OT. It's a really complex topic, and in fact, one of the engineers that worked on Google Wave, which was Google's kind of big push into OT, said this. I'll read it out loud in case you can't read. Unfortunately, implementing OT sucks. There's a million algorithms with different trade-offs, mostly trapped in academic papers. The algorithms are really hard and time-consuming to implement correctly. Wave took 2 years to write, and if we rewrote it today, it would take about that long a second time. So that's something. Fortunately, Joseph Gentle, even though he was obviously frustrated by this experience, did the world a favor and wrote share.js, which is an open source implementation of OT. It's built on Node. OT requires both a client-side JavaScript library as well as a server-side JavaScript library, both fairly complex. And a few months back, a company called Lime Apps sponsored my colleague Chris Selden to write Ember Share, which is an open source Ember layer that sits on top of Ember.js, on top of share.js, and particularly on top of its JSON support. If you want to play with it, you can go to embershare.com. It's a pretty cool demo there. Let's look at how it works. So share.js provides you with a node server and a client library. They communicate over WebSockets. The Ember Share store kind of sits and is able to talk to the client library. And so when you initialize a document or look something up, it grabs it through this library and returns a wrapped version. And that version is wrapped in two objects, a combination of two objects, share proxy and share array. And the responsibility of this object is to present a very simple Ember interface to you as a developer while dealing with the share.js compatible JSON mutations under the hood. And so in the case of share proxy, you're mostly doing .get and .set, as you might expect. It uses unknown property to do some cool stuff there. And then with share array, you've got a ember.enumerable. So you've got all the classic things that you're used to dealing with an array. But when you remove an object, that's going actually all the way through the pipe back to the back end and then coming out to any other clients that are connected to that same document. Yep, some cool arrows. So those are the four patterns. And in thinking about these, here's where I think we're kind of at. When you get these things working in an Ember app, it's practically magical because you actually end up needing to write fairly little code because of the data binding that's kind of at Ember's core. It's awesome. But there is where we have a lot of conventional solutions today for solving lots of problems in Ember, we don't really have any kind of conventional solution for solving push yet. So my hope in sharing these patterns today is that we can start together kind of as a community to experiment with these ideas, create these cow paths through the wilderness that we can eventually pave over and come up with a widely shared library that's either in core or not, maybe through the new Ember CLI add-on system that we can all really embrace and start building on top of. So with that, that's my Twitter for details. Thanks.
Questions, hands up in the air. Let's go. Come on, there we go, yes.
This isn't really a question so much as a call for help. I actually implemented Find Subscribe for my game. And
cool.
If anyone wants to talk about it, you should come find me. I'm the guy with crutches.
Awesome. Good stuff.
In the back, it's like Sam. Yeah, the video doesn't pick it up though.
While the mic's going, just by show of hands, who has implemented either one of these or something similar in an app? Just raise your hand, just out of curiosity. Cool, so that's probably about 20, 25 folks in the room. Awesome.
My question was, has your work doing this stuff touched into the realm that Orbit has gotten into with disconnected sources and any of that kind of stuff?
So in terms of disconnected sources, Share.js certainly has support for that kind of thing. You can turn off your internet and then have changes play back. And so the Ember Share Library implementation on top of it, I believe, handles that well. The other ones, not so much.
Anybody else? Okay, all right.
Cool.
Thank you
Thanks,
very much,
everybody.
Luke.